So basically, ladies and gentlemen, when we are going through this here, I have y equals x squared plus 4x plus 5. And basically what we're looking into doing for this problem is we want to be able to solve it. We want to be able to solve for x. And previously we looked into factoring. If you guys remember, when a equals 1, we look into this factoring technique of two numbers that multiply to give you 5 but add to give you 4, right? Even when you do your a times c. But the problem comes in is we can't think of any two, bless you. There aren't any two factors that we can have that multiply to give you 5, add to give you 4, right? So therefore, the quadratic formula can work, will be helpful to us and be able to do it. Now, there are a couple things that I want you to do that we're going to do with this. But the next important thing in regarding to that is also you can use the quadratic formula even if you can't factor. But you have a trinomial that's at least a quadratic, you can use the quadratic formula. So the first thing we're going to do is step number 1, which is label what a is, what is b, and what is c. So for all of your problems, this is what I'm going to have you guys do. I want you to label a, b, and c. All right? So our a in this case is, if you guys remember, what is a, b, and c? A comes from our standard form of our equation. Y equals ax squared plus bx plus c. So a is your coefficient of your quadratic term. B is your coefficient of your linear term. And then c is your constant. So in this case, I have 1, 4, and 5. All right? The next step that we're going to do is we're going to find what we call the discriminant. And what the discriminant is b squared minus 4 times a times c. All right? So we're going to want to determine what the discriminant is. And I'll go through all the types of solutions you can have. So basically, I'm going to take my discriminant. I'm going to plug in the values. So here I have 4 squared minus 4 times a times c. So therefore, I have 16 minus 20. So therefore, I have negative 4. All right? So since I have negative 4 here, since my answer is negative, I'm going to write in, I'm going to have 2 complex roots. We'll call it roots, solutions, x-intercepts. And then the last thing we're going to do is now we're going to use the quadratic formula to find actually the rest of the actual values. So the quadratic formula is x equals opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, what's nice about using the discriminant is if you guys look under the radical, you guys can see that the discriminant is what is under the radical. So therefore, rather than trying to have to memorize the formula and the discriminant, if you know what the discriminant is, then that's what's going to go. You can just rewrite that under there. All right? Then we just plug in b and 2a. So in this case, I have opposite of b. So my b is 4. So opposite of b would be negative 4 plus or minus the square root of negative 4 divided by 2 times 1, which is a. All right? Now, basically, ladies and gentlemen, it is important. I'm going to go over this. It's not going to be you guys just need to know as far as simplified what your possibility. As I mentioned, this is 2 complex roots. OK? I'm not really too sure on your test. If on a state test, you might just say no real solutions. OK? Because basically, ladies and gentlemen, you can't take the square root of a negative number, right? So taking the square root of a negative number, there's not going to produce any real solutions. However, there are 2 complex solutions. And those 2 complex solutions is taking the square root of a negative number. We can rewrite that as taking I. Anytime you have the square root of a negative, just think of taking the square root of a negative produces I. So therefore, this is negative 4 plus or minus 2I divided by 2. All right, so basically what I did is I represents my imaginary numbers or imaginary system. And therefore, my last thing is I'll divide the 2 into both of these. So negative 2 plus or minus I is my final answer.